Before we start, I just want to extend a few thanks to some people that were very critical in making this event happen. First off, Arunima Kumar, could not be here today, but she was essentially the one that kept me on the straight and narrow, helped me with all the communique and all the emails and everything that went out. So thank you to her. Also wanted to thank our HR and recruiting partners, specifically Diana and Nicole, for helping get the word out as well. All the volunteers today that have taken time out, again, to be here for this event, thank you. And finally, to Catherine Schultz and Kumar Upadhyay for their guidance and their support. I'd like to start the evening off by playing a very short video. This was recorded by two of our rockstar executives talking about Autodesk and why they chose to come to Autodesk to further their own professional careers. Give me 1 second here.
Well, Sam, the reason I joined Autodesk is I saw an opportunity to take the power of the cloud and the power of technology and apply it to dramatically underserved industries. Construction is a $10 trillion a year business. 30% of that is at waste. Yeah. And by starting to build systems, the engineering cloud, we can start pulling that information out. We can start making it possible to build not only more inexpensively, but also more efficiently. And that's really exciting to me.
Yeah, it's a big deal. For me, I always think about the number of heartbeats that our lives are divided into. And not only how are we spending them with each other, what are we building to support other people's use of their heartbeats? The thing that blew me away about Autodesk is I've spent much of my career thinking we're writing software to change the world. I've made software that talks to software, bits that move bits. At Autodesk, we make bits that move atoms. So you should only care about this if you live in buildings, consume products, or watch movies. So how do we change the world through the world's makers? Mm-hmm. So that excites me.
I think one of the things that struck me when Autodesk reached, I retired again. I retired three.
That was your third retirement.
I've retired 3 times now. My wife has told me I don't get to unretire again, so I think this is the last gig.
Well, please stick around for a while.
Yeah, I'm planning to. There's a lot of work to do. But what really struck me was Autodesk software is involved in pretty much everything we see, touch, or experience every day. We're just not well known in the cloud world, mm-hmm. and yet we are very well known in all of the other industries.
Well, that's one of the fascinating opportunities, right? Manufacturing, also a $10 trillion industry with a ton of waste. Construction, over $10 trillion with tons of waste. 13% of global GDP is in construction. Mm-hmm. So our opportunity to start to change the curve for these industries, to make them more efficient, to take care of more people better with less negative impact on the world is a really big deal. And nobody has yet built a cloud to do that, but that's what we're doing.
Absolutely.
At Autodesk University last week, I got to see an extraordinary setup where a rolled steel cartridge was being run through an automatic machine that was milling out little bits of struts. Now, those struts collectively only cost a couple $1,000s, and they were going to be built using very basic labor to create a clinic in Africa. So some of the kinds of things that we think about with moving bits, moving atoms, moving emotions is we help people take care of what they really care about, which is each other.
From your perspective, what kind of people are we looking for, and what kind of people will thrive here?
We're building teams out of folks who question authority, people who know their skills, who want to continue to learn, and then ask, why are we doing this thing? Because the work that we're doing is so new and it's so fraught with opportunity and risk that we want everybody to be sort of fully formed in their own mind, which brings me to fully formed teams. The idea of being on a balanced team where software engineers, software test engineers, site reliability engineers, experienced designers, product owners, scrum masters, product managers, architects are all treated in a coherent way and are all organized into teams where they can take care of what they care about and take care of each other. That's absolutely crucial to our success. So if that's appealing, those are the kinds of people who will work really, really well in this organization.
Thank you. Now, I'd like to invite up Diana Van Kessel, who's a senior technical recruiter here at Autodesk, and she's just going to talk to you about some of the open positions here at Autodesk and how you can apply.
I've been at Autodesk for about 2.5 years, and I recruit for more or less the senior DevOps engineers, site reliability engineers, product managers, and managers that manage all those people. So right now, you want to do the next one? I just want to, for those of you who are interested in applying to jobs, or maybe now or in the future applying to jobs, just kind of wanted to let you know, right now, Autodesk has roughly 53 open positions in the engineering realm. So most of those positions are, of course, San Francisco, San Rafael, but we also have locations in Portland, Novi, Boston, and New Hampshire. So a lot of people don't know that about Autodesk, but we are not only all over the US, we are global, but in the US right now we have roughly 53 engineering open positions. And when you apply to a job, this is kind of what it looks like. These are just examples of a couple positions that we have open, and you just kind of, you go to the engineering section of autodesk.careers.com, and you apply to a job, and you just click apply, and it takes you right to the job. We also have something called Autodesk Talent Community. So for those of you who just want to know more about Autodesk or get more information about Autodesk on a sort of quarterly, like bi-quarterly, we send out emails sharing what's going on at Autodesk, what's going on in employment in Autodesk, what kind of new hires are going on, and what kind of events are going on. So it's always nice if you're not interested now in moving your position to another job at Autodesk, just learning more about Autodesk by signing up through our talent community group here at Autodesk. And that's really it. That's all I have. Thank you.
Thank you, Diane. All right, let's get down to the real reason you guys are here. Observability. So it's something that's up in front and center right now in today's operational world. How do we make decisions faster, and how do we catch growing problems earlier? We have a pretty great lineup of speakers here today that will help shed some light on their take on observability and how they think we should be doing it. So the way this is going to work, each of these presenters will give their presentation, and we'll have a short Q&A. If we have time at the end, we will open it up, and we'll ask the speakers all to come up, and we can tag team them. Without further ado, our first speaker, Daniel Spoonhower, or likes to be affectionately called as Spoons, who's the CTO and co-founder of Lightstep. Go for it.
Great, thanks. Yeah, so my name is Spoons. That's what basically everyone calls me except for my parents. And I'm the CTO and a co-founder at Lightstep, where we're building tools to help developers build, operate, and maintain systems with confidence and at scale. I should say we're also hiring, so if any of this stuff is exciting, you should come talk to me afterward. And then, I want to talk tonight a little bit about distributed tracing and why you might want to trace your distributed systems. And before I start, I just want to also say that I love feedback. A bunch of the stuff I'm going to present is a little bit new, and so if you have any comments on the presentation itself, I'd love to get them afterward, or if you just want to catch me on Twitter or something like that, that would be cool too. Okay, so you want to trace, or at least some of you want to trace, maybe. Maybe some of you don't want to trace. Maybe some of you don't know what tracing it is. So why don't I kind of give some context and bring everyone up to speed. So as you all learned in school, there are 3 pillars in observability. Those are metrics, logging, and distributed tracing. And so you're not going to be surprised when I say that metrics will show you graphs that look like this and let you observe some value, usually a scalar or some sense over time, understand something about your system. And likewise, if I say logging, you're going to think about a tool that looks something like this. It has events. You can search and analyze them in some way. And distributed tracing, maybe it looks like this. I'm going to show some screenshots from our product. There's some other products that do this as well. I'm going to use ours because I have an example that I know that I wanted to use. But all these things you can kind of see, it looks a little bit like a Gantt chart. Does that make sense? I don't know, maybe I do too much project management these days. Yeah, roughly, just to kind of think about what's here, like the trace itself kind of, in this part right here, this is like, you can think of this as describing time from left to right. And then from top to bottom as you go from the top of your stack down to the bottom of your stack. And each sort of bar here represents the work done on behalf of this request by some service or some component of a service. And then at the very top, there's sort of a summary of that. And then over on the right here, some other metadata that I'll talk about later in some way. So just a quick note on terminology. This is a trace. This is this sort of representation of an end-to-end request. And these individual colored bars in here, these are spans, kind of the terminology or the jargon for that. And a span, you can think of it like a timed event. It has a start and an end. It has some service that it was run by and some operation, along with some other metadata. Cool. Okay, so we all know what distributed tracing is, I guess, in some sense. But I want to sort of undo a little bit of what I just told you. So we often describe these three pillars as these sort of discrete, like three things that are totally separate. There's a lot of space between them. And that's sort of the way that they're presented often as these three tools from your Googles or your Facebooks or your Twitters or whatever, as the tools that you need to understand your distributed systems. But I actually want to try to get folks to reframe that a little bit and think about them as just three kinds of data. And just because you have three kinds of data doesn't mean you need three separate tools. So it's true that the data and the way that you generate it from your application in terms of the code that you're going to write to do that is going to look pretty different. And maybe the typical kind of user interface for rendering that and visualization is going to look different as well. But that's not the only way of rendering it. And just because there's three different ways of writing the code doesn't mean you really need three separate pipes for handling this data. Because, I mean, let's sort of step back, like, why are we doing this? Like, what's the point of a metrics tool? It's not just to collect metrics data, right? The point of a metrics tool is to be able to answer questions about how the behavior of your software has changed. And the point of a logging tool is not just to collect logging data. It's to be able to answer questions about specific events when they occur and how frequently. And similarly, the point of a tracing tool is not just to collect tracing data. It's to do something else. So one way to think about this is to think, what can you learn from a trace? So there's a lot of different things that you can think about when you think about an end-to-end request. One of the most common ones for tracing that comes up is latency. How long did it take to service a request? And with tracing, you can think about things like the critical path. What was the bottleneck in terms of serving that request? You can also think about where there might be some structure that could be better. So maybe you have a series of sequential calls that could be performed concurrently. Tracing can put some context around what you're doing, either thinking about the services that are calling your service or the services that you're depending on. You might also think about context in terms of the release of your software, the data center that you're running in, maybe the geographical location of your users. Maybe you even want to tag the trace in some way through your customer. Tracing is also kind of interesting in that you can see white space in kind of different ways than maybe you can in other tools. So if you think about the span that represents a client request and then the server span that sort of is paired up with that, there's some gap between those, and that represents the network latency on both sides. If you see a long span, that also might just be a place, it could be something that's taking a long time, but it could be a gap in your instrumentation. So that might be somewhere where you want to look and you want to see more about what's going on. And of course, you can have events that are associated with these things as well. When you learn all this sort of stuff, what can you do next? Well, now you can think about which service do you want to roll back? Which code do you want to optimize? Which customer maybe should you get in contact with? If you know that they're maybe going to see some not so ideal performance behavior, maybe you should reach out to them proactively. And maybe it'll tell you which team to blame in the end. And kind of stepping back, like these sorts of use cases I feel like fall into sort of two categories. If you're on call, you're thinking about root cause analysis. You want to figure out, maybe you're being proactive, you see some smoke, you want to get ahead of downtime and take some action, or maybe you're in the middle of an incident and you want to understand how do you quickly remediate that. Tracing can help put context around that, understand what you need to do. Kind of on the other side, you might be thinking about performance. Maybe you're writing the first line of a code for your service, or maybe you're optimizing something that's already out there. Tracing is going to be able to put the work that you're going to put into performance and allow that to be more efficient, right? So when you think about what really matters to your users, what is the performance behavior that they're going to see? Where's your SLO? That's going to allow you to line up the work that you do, maybe in your service, with what is actually going to make a difference to your users. So I want to go back to our trace and kind of try to do a little bit of analysis here. This is kind of a simple trace. Traces can have like hundreds or thousands of spans. This one has 6. It's still kind of interesting in some ways. If you know anything about tracing, you're probably looking immediately down to this part here and this long span here. It says SQL select one bento gorp client. So that's taking 1.1 seconds, and that's sort of the bottleneck. So if we're going to optimize anything here, that should be it. That's 80% of the overall request, and even more of this thing that we call the bento service. Optimizing anything at the top of the stack is not going to really make any difference. Some other things that you can kind of see here, probably sort of lower order bits, like up here in this, there's like a little bit of a gap between the client and the server. These are gRPC initiated spans, so one on the client, one on the server side, like I was saying. And it's like 60 milliseconds for an inter-data center RPC call. It's a little long, maybe a little suspicious. And then I was saying there's some context here, you can say. So this is actually initiated by this caching structure we have. So maybe this is not the best example from the point of view. Like this is actually taken from Lightstep's meta monitoring. So this is where we're monitoring our own services. But this isn't something that one of our users saw. This is a background process that's refreshing a cache. But I wanted to use like a real example, and this was something that one of our engineers was looking at, and I think there's kind of a nice story around it, so that's why I wanted to use it, even if it's not quite the perfect example. Anyway, even before I told you any of this, you're probably thinking, Spoons, your database is slow. Like you don't need distributed tracing. You should just like there's a lock contention, or you need a bigger instance, or I don't know, maybe you need a new index or something like that. So you all have your theories. And what I'm going to say next, I'm not trying to like pick on you or anyone else or whatever. This, so like I said, this doesn't come from a problem where we're trying to debug in our production systems. This was actually one of our senior engineers found this as he was implementing a new feature. And it was surprising, the context that he saw this thing in. And his assumption was that there was a bug in the feature that he was implementing. He thought, new code, my code must be wrong. But in fact, there was a minor but real thing happening in production at the time. And so it turns out his intuition is wrong. And if there's one thing you take away from this talk, your intuition is also wrong. For a couple of reasons. One, systems are getting more and more complex, not just microservices and serverless, but all of these additional layers of abstraction from VMs to containers to app frameworks. And not to mention cloud services, third-party vendors. There's just like so many things out there that you as an individual are just not going to be able to keep track of all of them. 2, these systems are changing faster and faster, so it's not only your own team's continuous delivery process, but every team around you, and never mind when your cloud provider decides to reboot your MySQL instance for some reason. And 3, when I say your, I mean not just your here, but everyone on your team, right? You need everyone on your team from the least experienced engineer to the most experienced engineer to be able to respond to production incidents with the same level of confidence and the same level, the same tools that are going to get them to the point to resolve those incidents as quickly as possible. Okay, so back to our story. What's going on here? So if you were thinking about this SQL select one span, you're right in a way. Like this is the problem. Well, let me get to where I go. So what we really want to do is like understand like what's different about this thing, right? Like, is this normal? Is this what happened all the time? Was something new that happened just now? So let's put some context around this. So this is the same data. This is a set of a bunch of these operations, again, SQL select one, that are happening around the same time as the trace we just looked at, kind of a few minute window. And that one sort of lies over here somewhere. It's like a little more than a second. And it's a histogram, right? So you can read this. The ones on the left-hand side are the fast ones. The one on the right-hand side are slower. So this is pretty slow. Not maybe the slowest, but pretty slow. And then the height, the y-axis, is showing the frequency or the number of occurrences of these spans of these different things. So sure, it's slow. There's a lot of faster ones. This is log. Also, so kind of put your mind in log mode. One thing that's actually kind of interesting, it's pretty even. Like you might expect a longer tail distribution, but there's actually a lot of pretty slow things going on here. It's not like it tapers off that quickly. So the question we kind of want to be able to answer now is what makes the spans on the right-hand side different from those on the left? And so let's just say that we look at those spans. There's in this, I don't know, 2 or 3 minute window, there's about 100,000 of those. And it turns out we don't have to look at all 100,000 of them. We just need a sort of a sample and look at those and see what makes them unique. And it turns out what he did is do that, and it turns out that in many of those, there's this tag here that says peer host bento, public bento, 864 something or whatever. And this number, 0.63, is a coefficient of correlation, so it's sort of saying there's a reasonably high likelihood that if the trace had this tag, that it would appear on the right-hand side, and a reasonably low probability if it didn't have the tag, then it would appear on the left-hand side. So what it turns out, the problem here was that it has actually nothing to do with the database. The database is totally fine. The host that this service was on was just overloaded. And it's a sharded service that was running on a couple of different hosts, and this one was performing much worse than the other ones. And this is, again, one of our more senior engineers. He didn't quite believe it, but he went to another monitoring tool, looked at the time series, saw, in fact, that host was overloaded at the time. It wasn't a bug in the code. It was just a thing that was happening in prod at the time. Funnily, it says peer host. It wasn't actually a host tag. So this tag didn't appear on the bento service tags, the one that we're actually sort of debugging here. It was on one of the clients of that service. So gRPC, the gRPC open tracing instrumentation automatically tags requests with a bunch of sort of standard stuff, and peer host, that is the host that it's about to contact, was one of those tags. And this tag, even though it appears somewhere else in the trace, was something that we could still use to understand what made those things different. Anyway, we could add, I guess, a tag for a host, but in this case, that actually wasn't necessary. Cool, so back to this thing. So maybe you saw it before. It was there all along. So this was one of the examples that actually sort of met this property that had this tag, but without the context of what was going on around it, we never would have seen that thing. We would have thought it was just a bug in the code, or that we needed another index in our database or something. And I guess the other thing is, like, we talk about tracing is looking at these sort of single trace views, but what was really important in debugging this was actually looking at this collection of traces. Looking at the individual trace was not actually that important. I guess we could kind of verify what was going on afterward, but really looking at this collection, looking at what the behaviors around the slower ones, comparing them to the behaviors of the ones that were on the faster side, was really what allowed us to do that. And back to kind of thinking about the three pillars of the three types of data, everything that's shown in this chart is actually based upon tracing data. It's the same data that's used to render the thing behind it. It's just that we've presented it in a different way. So thinking a little bit outside the box in terms of the UI that you want to present your tracing data with, or your metrics, or your logging, whatever it is, and thinking about what are the use cases that you're really trying to solve for, what are the questions that you're really trying to answer. So if we kind of go back to this, what can you learn from not just a single trace, but tracing generally? Like, of course, these are all things that you can learn, but now we can kind of put that in context. We can understand what's normal and what's not. And that's through analyzing this collection of traces. We can understand when we're looking at something like latency, looking at critical path, is that something that's gotten worse today than it was yesterday? Is it worse for certain customers? Is it worse for certain downstream services that are calling us? Or is it worse, in this case, for instances of a service that are running on a particular host? Likewise, for looking at things like network latency, critical events, they're all signals that we can use in trying to understand what's actually impacting what matters. That is, thinking about downtime, thinking about our SLA, and thinking about the performance that we're providing to end users. And as I kind of mentioned when talking about our sort of intuition and these things, distributed systems are not just complex but dynamic, right? They're changing all the time, and we shouldn't really be in a point where we are looking at a dashboard, we're looking at a trace, we sort of stare up at the ceiling, we start thinking, and we're theorizing. Like, that's bad. If we're in that state, like, it's not going to go well, because one of our more senior engineers, probably many people on your team, are not going to be able to understand, not going to be able to just hypothesize the answer out of thin air. Understanding that change is critical to understanding these things, and so having the data behind that is really critical. Okay, so sort of a cheat sheet of the sort of couple points that I talked about. So first of all, tracing, metrics, and logs. These are three data sources, three types of data, not three different tools. You might be used to them in sort of these three different UIs, but try to step away from that and think about the use cases. Think about the problems you're trying to solve, the outcomes that you want to achieve, and then kind of work backwards for how you can use that data to do that. I think beyond individual traces, I think when folks use tools like Lightstep, like some of the open source tools like Jaeger, they think about as individual traces and trying to understand what happened on a particular request. But what's really helpful, I think, is understanding what's normal and what's not, understanding why it's not normal. And then last, like I said, your intuition is maybe not as strong as it should be. I guess this is kind of a call to all of us as computer scientists to do some more science and use the data to think about how we can use that data to really build stronger hypotheses and not just sort of imagine what went wrong. And yeah, happy to take questions.
So just raise your hand if you have questions for Spoons. We have a mic at the back there, mic in front here. Just wait till the mic gets to you. Oh, sorry. Questions? Man, you guys know this stuff then. Oh, there's one here. If you can just introduce yourself.
My name is Sam Caldwell. I'm a senior site reliability engineer for Invitae. Are we talking just tracing at layer 7, or are we also talking tracing at layer 3? So I can see when the network goes to hell on me.
Yeah, the way I think of it, so L7 is really important because that's where you're going to get data about customers, where you're going to get data about transactions. I know there's some work in getting that out of the network layer, but it's pretty hard to do that reliably. And I think at some level, this is sort of, all these tools, if we're in a sort of DevOps mentality, are for developers, right? And we are people that write code, and really, I think of this instrumentation as just expressing important features of your code that you want to be able to see later. So to me, it starts with level 7 because that's, again, where your SLA is going to be defined. That's what's going to matter to your end users. There's really important stuff happening down at the network layer too, and I think it would be great to figure out how we can extract some of that data. But for me, it's like I always want to start with like, sure, we had this host. That was a little bit slow. Should we do something about it? Eventually, but I don't want to page anyone because this host is overloaded because the only thing it was impacting was this background refresh process. And that's not something I want to wake someone up for. So definitely important, but I would think of it as a way to explain variation among the kinds of things that you want to understand.
To give some context, a year and a half ago, I was on an incident where I didn't get pulled into the incident until a quarter into the incident. Devs had spent a quarter or more troubleshooting through code. Turns out it was a router.
Sure. So getting that data in, totally agreed. Yeah. I think one of my first times I was on call at Google, I got paged and I woke up and I saw what was going on, and like a transoceanic cable had been cut or something like that. It's not my problem. Not what I do.
Any more questions for Spoons? It's at the bottom. Hang on. Coming to you.
Hi, my name is Steven. So I'm curious to know, definitely I think that thinking about collections of traces is a really great idea. How do you kind of reconcile that with the other point you were making about like tracking changes over time? Do you think that traces could become metrics, should help inform metrics, and how do you tie those two together?
Sure. I mean, to me, there's sort of two meanings of metrics. One of them is I want to emit a gauge right now that's 97. That's my queue size, whatever it is, right? But then there's another version of metrics which is more about kind of the UI and saying I want to see a graph where something's going up and down over time. And there's no reason why you couldn't generate a graph of something going up and down over time using data that came from a trace. I think there's going to be, yeah, like if you look at like the Open Census project, like these things are actually merged even at the instrumentation layer. And that's, I think, sort of a foreshadowing of where the tools are going to go, that we're going to merge these data streams at some point. Yeah.
Hey, Spoons, Sam. Given the shared Google experience, we had a tool that would let you see application lifecycle events and correlate those to traces live as well. Very curious about how you think about this, because of course, like any ex-Googler, I want all those tools, but commercially, like for Lightstep.
Yeah.
So application lifecycle is a really good harbinger of subsequent failures that we'll use the dtrace system for.
Yeah, absolutely. So yeah, to me, that's just like another signal that you want to get in here. Again, thinking about like what are the different streams of data that you can get in? Absolutely, get things about your application lifecycle in there, just like things about your infrastructure, your network. But then think about how do you create sort of a smart set of pipes that can extract that in different ways. But yeah, that's what I would go to if something's gone wrong, is figure out what changed most recently. The trick is it's not always your service, right? It's like your downstream provider or that other team that just did a release or a bad config over there somewhere.
Anybody last question?
Okay. Round of applause. Oh, sorry. One more.
I just wanted to ask real quick, this is Adam. Do you see a huge gap in the tools right now in this area for tracing, or do you think it's just we need to be a little more clever about incorporating it?
Yeah, to me, the gap is like, if you think about there's sort of a pairing of orchestration and observability. And the orchestration tools have made tons of leaps in the last couple of years. There's a lot of great tools that'll get you out there and like building all kinds of systems that'll auto-scale in all kinds of crazy ways really fast. But what hasn't kept pace with that is the observability tools. I think a lot of the tools that we're still using are sort of from the last era. And I don't know, one of my co-founders likes to say that like the transition from sort of like a VM-based architecture or in a monolithic architecture to a microservices architecture is bigger than the transition from bare metal to VMs. It's more like the transition from like shrink-wrapped software to client server. Like there's just a whole other set of tools that you're gonna need to understand that, which I think why we're all here in a way. But that's, I think, really, the gap is like, generally, in observability, how do we catch up with the orchestration tools in ways that actually let us see what's happening now that everything is so magical?
One more.
Great talk, enjoying it. Any recommendations on when things go async callbacks and webhooks like? What's the best practices around this?
Yeah, a lot of the tracing technology, like, so what we did at Lightstep and what was done sort of through the Zipkin Jaeger, all of that leads back to some work that was done by one of my co-founders at Google, and they were really focused on latency for these end user requests. So, you know, requests that should take on the order of hundreds of milliseconds, maybe a few seconds if things have gone really off the rails, and where you sort of had like a very clean fan out, a lot of servers that are basically doing web search. So I think, yeah, there's a lot of open questions in how we do async and how we do more complicated fan in, fan out kinds of things. Yeah, I mean, again, this is sort of like, let's get the data, and then let's figure out how do we visualize that, how do we analyze it in a way that we can make sense of it.
All right, how about a round of applause for Spoons?
Thank you, great questions.
Okay, next up, our very own Vinayak Lokhande, who's a principal solutions engineer here at Autodesk.
Thank you. Hi all, welcome to Autodesk. I am Vinayak Lokhande, Principal Solutions Engineer, part of Site Reliability Engineering team. Today I'll be talking around observability at Autodesk, why, what, how, some of the learnings, and what's next. So if you look at traditional applications, we have maybe few hundred or thousands of users interacting with applications typically hosted out of data centers. These applications would have maybe load balancers, few set of servers, memcache, databases. The point I'm trying to raise here is there are finite set of components here, and you can do proactive monitoring on these components. Well, I'm not saying this is not complex. I still love the fact that you can always hop onto a Linux box, or better enough, you know, I can just run into my data center, hop onto KVM switch, and just go to the console. Today's modern systems or modern applications have millions of users. Typically, these millions of users are interacting with applications which are hosted in cloud environment. These applications are interconnected. Right? They are interdependent on each other. You can almost replace that with a spaghetti, wherein, you know, if you pull a thread, maybe the other applications will be impacted. Definitely they will be impacted, not maybe. yes, you can definitely go to the traditional monitoring approach, and in fact, you should be doing that, right? But that's not alone enough here. That's what brings us to observability. And observability is a word which is borrowed from the control systems, and it's essentially measure of how well internal states of a system can be inferred from the knowledge of its external outputs. I would also like to quote Charity here, and as per her, monitoring is all about known unknowns. Observability is about unknown unknowns. Essentially, monitoring you can do proactively. So yes, you definitely need monitoring. You need metrics for your applications. And these metrics should ideally be monitoring the key performance indicators of your applications, SLO, SLIs of your application. But whenever there is an issue with one of these indicators, you should be able to do journey test and pinpoint where is that problem. That's where tracing comes into picture. And last but not the least, you need logging. So if you see, these are the three main pillars, and like what Spoon was saying, you can say these are the three kind of data which form observability. The other day I was discussing with TJ, hey, what do you think, what is observability? And he quoted something like this: it's not rocket science, it's common sense. Well, if you rethink this, what are we talking about here? We are talking about metrics, monitoring. We are talking about logging. They have been here since the beginning. But what has changed is the way we are approaching it. So over the next few slides, I'll be talking about how we attempted to do observability at Autodesk. Before I go into the architecture of the system we built here, I'll walk over some of the concepts here. Structured log data. So structured log data plays a very important role in today's complex systems. If you have unstructured log data, which is in different format, well, cross-service tracing is very difficult or almost impossible. Performing forensics, monitoring, and analytics on log data is very difficult. And deriving SLO, SLI matrix out of that log data is almost impossible. So what we did here is we came up with structured logging via standardized log data model. Now here this was based on open tracing specification, and in this we used to annotate log records with distributed tracing states. We came up with SDKs using which services can log in structured format, in JSON format. So here's a sample log record. As Spoon mentioned, it has span IDs, which typically identifies the given log record. This can also be, you can call it as the trace ID. Then there are a couple of important elements here. For example, the name of the operation, how much time that operation took, start, end, so forth, so on. So before I go into the architecture of the service which we built here, I would like to summarize, or I would like to walk you through some of the AWS managed service which we used. So we used AWS Kinesis Data Firehose. Kinesis Data Firehose is an AWS managed service which can ingest large amount of streaming data, and it can deliver to destinations like S3, Elasticsearch. We also used AWS X-Ray. This is Amazon's tracing solution, we can call it. You can essentially feed in data to AWS X-Ray, and it can generate pretty service maps. Then we also use Kinesis Data Analytics. Kinesis Data Analytics is Amazon's streaming SQL processing engine. Essentially, you can do something like this. You can hook it up with Kinesis Data Firehose, and you can write standard SQL statement and aggregate on data which is streaming live. We're going to see that in action in a minute. And then you have Amazon Elasticsearch service, which is Amazon's offering for managed Elk cluster. And last but not the least, we are using AWS Athena. Using Athena, you can query upon data which is residing in S3. So moving on to the architecture of the service, to begin with, we have data producers. These data producers are essentially EC2 instances, containers, Lambda functions, and all of them are logging using the SDK which we built. They are logging in the same structured format here. So the logs from the containers and the Lambda functions go to CloudWatch logs. So these structured logs, along with the logs coming from EC2 instance, are what are then sent to per service infrastructure. Now this per service infrastructure consists of Kinesis data firehose. Again, Kinesis data firehose can ingest large amount of streaming data, and in this case, it will deliver it to Elasticsearch service. Here what we do is we retain this data for 5 days. That's because Elasticsearch is costly. So the hot data stays for 5 days in Elasticsearch. So as the data is flowing in, essentially what we do is we fork it out and write it to a buffer S3 bucket. From here, we do two things with this data. The first, the one at the topmost there is the X-Ray Lambda. This Lambda will take these objects, the objects which is containing this structured log data, and it will convert it into service maps and feed it into AWS X-Ray service. Second down there is a log data transformation Lambda. This Lambda will essentially massage this data. It will do a bunch of cleaning up of this data, on this data, and it will write it to a central S3 bucket. So here, this central S3 bucket is where it will, it will reside for, let's say, 89 days, just for GDPR. So let's be safe, 89 days. And then you can use AWS Athena to query upon this. Again, AWS Athena is using AWS Athena, you can write standard SQL queries to query upon this data. Then, as the data is flowing into the Kinesis data firehose, you have Kinesis Data Analytics. Kinesis Data Analytics is Amazon's streaming SQL processor. Essentially, what you can say here is, hey, give me last 60 seconds of data, and on a given field, I want to do these aggregations. Let's say you can say, hey, for this operation, for this span duration, I want to calculate P99 or whatever it is, right? So these aggregations is what you can do with the help of Kinesis Data Analytics. And this aggregated result is what is then fed into CloudWatch matrix and what we call it as the SLI matrix for your application. At the same time, you have rich set of infrastructure matrix which you are getting for free from Amazon for your EC2 instances, containers, and Lambda functions, and they are also residing in CloudWatch. Now, if you pull the infrastructure matrix and the SLI matrix into a tool like Grafana, that's where you get the single pane of glass. Essentially, you get a holistic view of your application right from the infrastructure to the SLI matrix. So here's a sample X-ray service map which is getting generated using this mechanism here. You can see each circle is representing a given operation, and you can essentially find out error percentage, false, throttle, so forth, so on. The Amazon Elasticsearch service has Kibana built in that, and we are using Kibana widely here. You can build pretty dashboards here. This is essentially for any high cardinality matrix you want. You can derive it from Kibana. And this is what is the single pane of glass. We use Grafana here. If you take a closer look here, the first row is essentially coming from ALB matrix, right? And the next two rows are what they're coming from Kinesis Data Analytics. So, it's one of the operation in one of our service. For that, we have percentiles, various percentiles. The the success rate, the error rate, so forth, so on. Also, what we did is to simplify onboarding to this service, we came up with the onboarding mechanism. So I gave a talk at AWS reInvent wherein I have explained in detail how you can go about automating onboarding to this service. All right, let's move on to some of the best practices or learnings here. You know, this is, when we first built this, we ran into this. Typically, you know, if you have a dashboard or some solution, we'll try to measure whatever we can. But ideally, we should be measuring what we should, right? Otherwise, what happens is, what I would like to call it is, we end up with metric fatigue. So typically, if you have a problem, what we do is, we go and build just yet another dashboard, just for that problem, right? And over the period of time, we end up with huge amount of metrics that we never look at, right? And sometimes it also leads to what SRE book refers to as alert fatigue. It's like, hey, don't worry, this alert comes every day at this time, so let's just ignore it. So how do you avoid that? Well, you can monitor the SRE golden signals. There are some of the methodologies which are helpful here. You can definitely use RED, which stands for rate, error, and duration. Or you can go with USE, which is utilization, saturation, and errors. Or you can go with LETS, which is essentially coming from Google SRE book, which is latency, errors, traffic, and saturation. Error budgets. It's pretty important to monitor error budgets. So what are error budgets? If your application has an SLA of 99.95, it means you have an error budget of 0.05. Now, you should typically be monitoring these error budgets. Let's say if you have done a deployment and that has resulted in a bunch of errors. So definitely it has eaten up some of your error budgets. This is a very important indicator which you should be measuring. Percentiles. Yes, we all love percentiles, definitely, right? The first thing is, let's not average the matrix. But one of the most important things is, please don't average your percentiles as well. So, and one more thing I would like to bring up here is, just measuring 99 percentile for a given matrix, yes, it is definitely better than averaging. But what matters is, what's your sample set size? Yes, if you're talking about 1,000 requests per minute, 99 percentile makes sense, right? But if you're talking about 100,000, 99 percentile means you have close to 1,000 records, 1,000 requests, which are slow, right? Maybe 99 percentile is not helpful. You want to bump it up to 99.9 or something like that. Templates. As I mentioned, when we first built this around, we had a lot of metrics, a lot of dashboards going along. And what really helped us here was coming up with templates. So since we are heavily relying on AWS services, we are using AWS standard tools like ALB, Elasticsearch, EC2 instances, so forth, so on. What we did is we came up with templates and templates for ALB, wherein we said, just give me your ALB name and your Amazon account number. We take these two as the input parameters, apply it to the template, and essentially it will just spit out a nice dashboard with fixed set of metrics for ALB. So likewise, if you just list down all the components for your application, you are going to get your single pane of glass. Structured logging. I did talk about structured logging, but if we take a look at the traditional approach of doing logging, it's essentially a CSV format wherein we have, let's say, timestamp, maybe a log level, and there is some message. You know, we don't know what is that. But I'm not saying that it is not helpful, but having something like this would definitely be more helpful, wherein you have the same timestamp log level, but yes, you have a trace ID or a span ID for that given log record. You have operation ID, you have caller service, you have HTTP method, so forth, so on. I would like to give an example here. HTTP method, right? We ran into this issue wherein people were calling HTTP hyphen method, HTTP camel case method, HTTP space method, so forth, so on. Now, if I want to search for this HTTP method, which should be trivial, I just cannot because I don't know what they are calling their HTTP method as. Is it camel case? Is it something else? So forth, so on. So having a standardized structure logging format really helps here. Moving on, you should build your systems for observability. Structured logging is one of the important things here. One of the lessons we learned is if you're building your system, try imparting structured logging right from the beginning. If you try to retrofit it later on, it is really difficult. But if you're starting fresh, please try to do logging in some sort of structured way, which is uniform across the application. And then you should design your applications for tracing, or the traceability should be part of your logging. You can use some of the open tracing specifications, which I was referring to before. Code for failure. Well, I borrowed this from Cindy Sridharan's book on observability. So here I would like to quote this, which is, failures in today's complex, distributed, and interconnected systems are not the exception. They are normal cases. They are not predictable, and they are not avoidable, which is so true. Essentially, what we are saying here is you should always build your application anticipating that some or other application which it is going to be dependent on or which it is going to be relying on is going to fail. If you do that and if you start instrumenting observability right from beginning, it will be a huge help down the line. So what's next? Service mesh, that's something which is coming along recently. It gives a new dimension into observability. There are so many things service mesh offers out of the box. Let it be app mesh, let it be Kubernetes plus Istio, so forth, so on. So that's something which we are also evaluating. There are other tools available as well. For example, New Relic. New Relic provides a bunch of these things out of the box. And we are trying to find out how to integrate that with the solution what we have. With this, I would like to present you some of the references. The first one is, it's me presenting at AWS reInvent. There, again, I went over at stretch some of the issues or some of the performance limitations of the AWS, various AWS managed service. Essentially, how you can kill an Elasticsearch service or how you can kill an AWS Firehose. So you can always refer to that. And then, again, Cindy Sridharan, she had written a great book on distributed system observability. Last but not the least, Google SRE book. With this, thank you.
Thanks, Vin. Questions for Vinayak? Nothing? Okay, if you think of something else, he's going to be around later. Thank you, Vinayak. Again.
Thank you.
Last but not least, by any means, Charity Majors, CEO and co-founder at honeycomb.io.
People are still here. Cool.
Yes.
You can tell what I was doing. Fast too. yay, cool, this is great, this is a time saver. I'm going last so I can skip right over a whole bunch of stuff, which the other two people already said. Woo! My name is Charity. I brought some stickers. I don't know if you follow me on Twitter, but I have a bunch of stickers. I will put them on a table afterwards. They're like Lisa Frank art with Nietzsche quotes with words replaced with things like monitoring. So if you have that kind of sense of humor, you're going to love them. Also, I wrote the O'Reilly book on database reliability engineering, and if you have that book, I don't know if you know this, but they don't let you have mythical creatures. So we had to have a horse, but I have stickers to fix it. I can make a unicorn out of it. See me after class if you want one. I am an engineer, infrastructure engineer. You can tell that I'm from ops because this is how I feel about software. The only good diff is a red diff. How many of you here self-identify as operational infrastructure engineers? Software engineers, the rest of you? How many of you are recruiters? Just kidding. It's fine. We love you too. What is observability? If there's 3 things that I want you to come away like understanding, if you don't already, I'm going to attempt to hammer these into your head. But what is observability? First of all, I would like to say that observability does not have fucking 3 pillars. I really hate that. It doesn't even make any sense. You've got 2 data formats and a visualization layer. It's a very old thing that predates the more recent understanding of observability. It really drives me nuts because it doesn't make any sense. And you can Google Ben Sigelman 3 pillars for his co-founder's elegant takedown of this really annoying thing. There's not 3 pillars. I mean, they're whatever. Control theory. Observability is a measure of how well you can understand the internal state of a system inferred from the knowledge of its external outputs. And this is a control theory definition, and it was not really being used for software a couple years ago when I started Honeycomb. But I was having such a hard time coming up with new language to explain the differences that I had experienced at Parse and at Facebook between, the old way of understanding systems and the newer way of understanding systems. And so when you apply this to software, it seems to me that it's pretty clearly, it's a measure of, can you understand what's happening inside your system? Can you reason about it? Can you ask new questions to explain new states without having to ship new code? It's easy to ask new questions if you ship new code to handle the new states, right? It's a different matter if you're trying to gather data at the right level of granularity that you can ask, that you can understand any state that your system can get into. Oh, hi, former Parse people. Hey, doesn't scale if you have to write new code every time you have to ask a new question. And because we haven't had these observability tools, we have struggled with putting software engineers on call, I think, pretty clearly. Because what you're asking them to do is you're asking them to take, the world that they live in, writing code, blah, 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 functions, services, and then you're giving them a bunch of dashboards that speak ops and low-level systems. And it's such a gulf between, all right, here's my service that I'm trying to debug, and here is, uptime. Uptime aggregates and memory types. What's the difference between RMEM and, it's a different language, and ops has kind of sat here bridging this divide as a translation layer for a long time, explaining to software engineers what they see in these dashboards also doesn't scale. But in the glorious future that we are beginning to live in, services clearly need owners, not operators. Right? We need to empower the people who are writing the code to have a tool that speaks their language so they can understand what's happening to it as it becomes part of the system. Because as many people have said, as 2 people, as all the other people tonight have said, the systems are getting radically more complex. And the person who comes with the context in their head is going to have the best shot of debugging any problem in a reasonable amount of time. So how is this different from monitoring? Well, Greg said a couple years ago, Monodrama, he defined monitoring as the action of observing and checking the behavior and outputs of a system, its components over time. Now, I like to use these slides because Greg then went on to be the VP of engineering at a monitoring company. He really hates it every time that I show these slides. But they're also true. Bonus. monitoring is dead. That's what he said. This is why he hates me for showing this. It worked really well in the LAMP stack days, right? But it is an outdated model for complex systems. Complexity is exploding everywhere, but our tools were designed for this world where things were pretty predictable, right? I drew a graph so you knew that complexity wasn't increasing. I'm a music major dropout, dude. This is really the most you can expect from me. But like LAMP stack, right? You could look at it, you could look at a dashboard and you just knew in your gut what was wrong, right? It was very intuitive. This is a diagram of Parse a couple years ago. That middle blob is, I don't know, a few dozen MongoDB replica sets. We just let developers all over the world write code and upload it, and we just had to make it work. And write queries and upload it, and we just got to make it work, and not get in the way of the other people running queries on the same fucking shard. Never do this. It's a terrible idea. So that's Parse's infrastructure. It loops back into itself. You can see how this becomes complicated. And this is the national electrical grid. And when we're thinking about designing and operating these systems, this is what we should have in mind, right? Not the very predictable, LAMP stack model, but well, first let me say, if you can solve your problems with a LAMP stack, please do. Please do. Please do not do this unless you have to. The point is that more and more of us have to do this. But this is the kind of model you should have in your head, because problems happen that you cannot predict and could not explain. Some problems are hyperlocal, right? Like a tree fell over on Main Street in bumfuck Iowa, right? Couldn't have predicted it. It happened. You need to be able to very quickly, diagnose it, resolve it. Some problems are only going to be understandable when you zoom way out, right? Like if all of the bolts that were manufactured in 1983 are rusting 10 times as fast. It's going to create this systemic problem. You want to be able to detect it and, proactively remediate in some ways. And you're not going to see if you're just looking at a local level. And the other thing that I like about this is that it illustrates the sheer impossibility and undesirability of even trying to predict everything in staging. You're only ever going to see some categories of problems in production where you have representative concurrency, clients, and even then you still got the Michael Jackson problem, right? Michael Jackson dies. Well, I could not have predicted that was going to happen on that day. So this shift, to me, represents monitoring to observability is the same as saying the shift is from known unknowns to unknown unknowns, which, welcome to distributed systems. It's probably fine. It's not fine. Anyway, your system is never actually up. Many catastrophic states exist at any known time. And if you don't know about the things that are broken right now, it just means your tooling isn't good enough or you haven't looked hard enough. They're there. I find this liberating in a way. People, we used to get so uptight about, our dashboards being green, and that was nice, but it was wrong. Now we know that, right? You should never have to care about a single error. You do not care about an error. You care about a bug, and you care about representative times that bug gets triggered or hit, right? This is why sampling is so powerful. Distributed systems have an infinitely long list of things that almost never happen, except that one time they do, or 5 impossible intersecting things that have to happen in order for this sticky bug to be seen, which makes staging basically worthless. Is Facebook going to pay to spin up a copy of Facebook every time they want to run tests? No, they are not. It's a black hole for engineering time. Anyway, on to the next. I really want you to internalize this if you haven't already. I know some of you are ex-Googlers, ex-Facebook. But I'd love to see the pain in people's eyes, so let's just look at some examples. Photos are loading slowly for some people. Why? LAMP stack, right? Good old days. Every single one of us has debugged problems like this, right? Why? We're out of connections, run out of disk space, need more capacity. Monitor these things. These are very favorable for monitoring, right? You can predict them. You can see that they're going to happen. Characteristics of these systems are very friendly to intuition. Dashboards are great. That pane of glass where you can just ooh, it's that again. I can use my intuition. I can feel super good about myself. And the health of the system basically represents the experience of your users. If you have an uptime of 99.5%, then about 0.5% of the time, somebody's getting an error. Pretty evenly distributed. Best practices, actionable alerts, runbooks. You should never have to look at the graphs all day. It should inform you when there's something wrong. Like, we all know these, right? Cool. Now let's look at some of these same problems, but these are real ones taken from Parse and Instagram. I'm not sure what I'm supposed to monitor for. I've got more. Latency reverts to historical mean on Tuesdays. Not a cron job. I know what you're thinking. Not a cron job. I can do this all night. That one in Eastern Europe was one of my favorites. Like, pushes down. I'm like, it's not down. Like, it's in a queue and I'm getting pushes, ergo push is not down. And they keep putting back. Next day, like, pushes down. Go to take a look. I think that what it was we were running, because it was Android devices, and they used to have to keep a socket open, right? Every device had a socket open to the service, so we had auto-scaling groups, and we had added some more capacity automatically, and it rebalanced all of the connections, but the DNS record now exceeded the UDP packet size, which is fine. It's supposed to fail over to TCP, which it did, everywhere in the world except for one router in Eastern Europe. But this is easy to monitor for, right? It's just a different game, right? It's just a different ball game. Like, the world that you live in is it has to be that of a debugger, right? Not an operator. Your runbooks are not going to do shit for you. Sorry, I didn't check on the language thing. Not that it mattered. You need the mindset of a debugger who is following breadcrumbs, who is comfortable with the unknown, who is, stubborn and dogged in the pursuit of victory. I don't know. Scientific, though, the ability to form a hypothesis, test it, rinse it, and repeat. And let me tell you what staring at dashboards is not. Any of those things. When you're staring at dashboards, you've jumped all the way to the answer without actually asking a question or testing it, right? I see some people nodding. It's actually destructive to your ability to creatively debug a problem if you're staring at a bunch of answers, because you don't know what you don't see, right? And you start to think that what you see is reality, and you forget about, oh, well, this source seems to have stopped shipping data a few daes ago. It doesn't show up on your screen. You don't see it. Well, it helps to not look at it. It helps to, have more of an interactive approach to this sort of thing. I'm a vendor, by the way. I make a tool that does all these things. I just want to be super upfront about that. I feel like I would like to, anyone who wants to see a demo, hit me up at some other time. I will say, though, I was operating these systems and getting very angry at them, and that was why I made the tool. It did not go in the other direction. Characteristics of these systems. Unknown unknowns are most of the problems. If you're getting paged and going, oh, that again, you need to be this tall to ride this ride, and you're not yet. You should be somewhat puzzled every time you get a page, right? It should be not a support problem, it should be an engineering problem, which means it's new. There's something new about it. You cannot model the entire system in your head. You shouldn't try. The source of truth should not be my head and your head and everyone's heads. It should be in a tool that you all have access to, that you can ask questions of, that will give you all the same answer at the same time, more or less, right? And the hardest problem is often not debugging the code, but identifying where in the system the code that you need to debug is. And the health of this is super important. The health of the system is irrelevant. As an app developer, you should not have to give a shit. All you should have to care about is, can the request execute from end to end? That's it, right? That's it. The health of each individual request is of supreme consequence. The health of the system doesn't matter. Now, if you're on AWS and one AZ goes down, should you give a shit? No. No, you should not. Neither should your users. I'm saying you, like, to app developers. Obviously, your infrastructure people might raise an eyebrow. They shouldn't have to care much beyond that either. You should not have to care. The health of every request is all that matters, which is a problem given that most of our tools aggregate. They first shed all of that context of the request before they ever write to disk. Metrics are the devil. Best practices. This is an instrumentation game, start to finish. It's about events, not metrics, sampling, not aggregation, few of any dashboards, testing and production. And your reward for going through all this pain and suffering is very few paging alerts. A lot of what we do here is just like picking up stuff from the unknown unknowns and putting it in the support. Make it stop being an engineering problem, start being a support problem. Because those are predictable. Those are easy to staff. Engineering problems are not. Observability in the future, this is like my scorecard. But let's look at what it just means for systems. You need access to those raw events. If you cannot have access to the raw events, you can't ask new questions, right? If it's going to be observability, you have to have access to the raw original events. They can be sampled. Like, that's fine. Dynamic sampling that keeps rare events 100% of the time and common events less of the time is very cost effective. But if you can't do read-time aggregation, you're kind of screwed. You can only do the questions that you predicted you might have and stored the data in that format or aggregated in that format or whatever. Got to have raw events. You got to be structured. But I assume none of you're at this meetup, you cannot possibly be using unstructured logs anymore. I'm just not even going to speak to that. Context is everything, so you really want to be having arbitrarily wide events, right? And the width of the event is so powerful because you're saying all these things were true at once. All these dimensions describe this request. Because debugging is so often a game of looking for outliers and looking for what do these requests, or what do all of these errors have in common, right? What is the weird thing about all of them? Debugging is often less about understanding what happened and more about understanding what the world looked like when it happened, or what the request that errored looked like, which is why, I think that the right way to do this, ordering your events means that you can slap a tracing visualization on it, like magic, super cool. High cardinality is not a nice to have. This is mandatory. So when I say high cardinality, imagine you have a collection of 100 million users, right? Highest cardinality possible would be any unique ID, social security number, request ID. Quite high, but somewhat lower would be first name, last name. Very low would be gender, and species equals human is presumably the lowest of all, right? And metrics are all geared towards low cardinality, right? You can have your tags that are low cardinality dimensions. You append them to, the integers. And that's cool, I guess, but it's not good for debugging. Fine for monitoring. Shit for debugging. Because if you think about what information is useful to you as a debugger, it's all high cardinality stuff. Like I think I have, here's a list. All high cardinality dimensions. This is all the kind of stuff that you care about when you're debugging, right? Where was I in my rant? Thank you. Must be ordered, sampled is okay. So the right way to do this, like a big part of it, and it took me a while to realize this, a big part of making this data useful it happens before you ever ship it off, right? It's about persisting that blob in memory. So when the request enters a service, you want to initialize an empty event and stuff in, any context that you happen to have, language internals, any requests or parameters that were passed in, anything that you know, right? And then throughout the life of that request in that service, you just want to toss in any unique IDs, shopping cart IDs, user IDs, anything that might be useful for helping you find and find a particular event at some future date. And then when the request is about to error or exit, you ship that off in one blob. This is cool for reasons beyond just that it makes debugging easy. It's also incredibly write efficient, right? It's very write effective. Instead of having like hundreds of metrics that fire off every single time you have a request, you got one single write. Very efficient, very easy to sample, and you have all that rich context. And I forgot what else I was going to say. And the cost of adding yet more data to that blob is basically free. Right? So you're incentivizing your developers to just pile on all that context. It's cheap. They're not going to suddenly hit one of those write amplification upward trajectories that all of us who have ever used tags know and love. Yeah, high cardinality is not a nice to have. This is like a little bit of one honeycomb event. All this stuff, right? So easy to just slice and dice and isolate, an example of the problem. And then zoom back out and say, trace it for me. Who else is affected like this? It's cool. You care about each and every tree, not the forest. The forest is for, your monitoring tools, your aggregates. What you care about as a developer is every single tree. It's also a shift in perspective, right? This is an instrumentation game, but it's about, instead of having one piece of software, checking up on another piece of software, just like, how you doing? How's your thresholds, right? It's about getting inside the code and helping it explain itself back to you. And it speaks the language that is higher up the stack of software development. Now, in the same way that ops is now kind of everybody's job, it's every developer's job to know the basics of how to make your service scalable and reliable and operable. Ops is now much higher up the stack than it used to be, and very few of the only people at my company that look at low-level systems graphs anymore work at Amazon. I consider them my ops team. Aggregation is a one-way trip, destroys your ability to ask new questions forever. It's kind of the devil. And you can't hunt needles in a haystack if your tools don't handle these things. So how Honeycomb does all these things, we have a homegrown column restore. Any Facebook people here? That's too bad. Woo, couple. It's like we base a lot of it off of our experience with Scuba when we got Parse's data into it. And let me just tell you briefly a story. Around the time that we got acquired by Facebook, I was coming to the horrified conclusion that we had built a system that was effectively undebuggable by some of the best engineers in the world, doing all the right things, right? But Disney would come, somebody was come every day and be like, Parse is down. I'd be like, Parse is not down. Behold my wall full of dashboards. They are all green. Because arguing with your customers is definitely how to convince them that everything's fine. Because maybe we're doing 100,000 requests per second. Disney's doing 4. Mobile traffic isn't huge. It's never going to show up in my time series aggregates. So I'd go, or one of us would go dispatch, try and figure out what could possibly have gone wrong. Was it their fault? Was it our fault? Was it some neighbor that was noisy? And it could take a day or more. And I tried every tool out there and really thought we were just doomed. Then we got some data sets into Scuba. I think Travis got the first ones in. And we started, the time to figure out these complex systems problems just dropped like a rock to seconds, minute maybe sometimes. It was mind-blowing. And then I'm in ops. I moved on to the next thing and never really stopped to think about why until it was leaving Facebook. And that's when I went, oh shit, I don't know how to engineer anymore without this stuff, because it's become so core, not just to how I solve problems when the site's down, but how I decide what's worth building, how I make data-driven decisions about whether or not a feature is worth the time to add it, how I check myself as I'm rolling stuff out. What the code that I ship, is it doing what I expected to? Does anything else look weird? And that iterative process of just looking in production is something that I can't imagine being without. So to illustrate the exploratory way that you interact with systems in this sort of way. It's you're just following breadcrumbs. The questions never really end. You don't know where they're going when you start. Fundamentally, users do not give a shit about the system health. They don't care. They shouldn't have to. Should never have to think about it. All they care about is their experience. And so I've tried putting software engineering teams on call multiple times, and it has crashed and burned sometimes, and it has succeeded wildly sometimes. And the difference, in my experience, has always been the observability gap. Am I giving them tooling that speaks their language, that they can interrogate, and go back and forth between code and systems, and that makes some sense? If yes, they love being held accountable. They love having the ability and the power to understand the systems that they're building. We're engineers, man. We don't want it to be a black box. Unless we're so frustrated by being beaten down by bad tooling that is asking us, now you have 2 jobs. No, we can't give them 2 jobs. But right now, I think that it's incontrovertible that software engineers spend way too much time looking at fake environments and not enough time looking at production. Because all the time that you spend looking at any environment that is not production is not just wasted, it's worse than wasted. It's teaching you to have the wrong instincts, the wrong tooling, be scared of the wrong things, be not scared enough of the wrong things. Every single engineer should spend time every day looking at production. I'm not saying SSH into the box, I'm saying through the lens of your instrumentation. Every engineer should be looking at production every day. Oh, that was that slide. Anyway, watch it run in production, except no substitute. And get used to watching it when it's not on fire, right? If all you ever look at it is when something's wrong, you're not going to have the intuition, the gut for that you need. That was a rousing cry, but watch it run in production. And build better tools. Think about distributed systems when you're building them. And finally, you win drastically fewer paging alerts. Delete all of them. Delete all of them. All that you need are the big 3, request rate, latency, errors, maybe saturation, and then some end-to-end checks that traverse the key code paths that make you money. That's it. Everything else, just delete it. And you can do that if you have the confidence. You can slice and dice that you can go from knowing nothing but hearing about a symptom to diagnosing the source of the problem in seconds every time. It's just a tooling problem. Thanks.
Thank you, Charity. Questions for Charity? Here we go.
I'll do it afterwards if you want me to. I don't want to take up their time.
Any other questions?
All right, so I've got this one question thinking forward into the future of observability. All right, there's always those times when you're troubleshooting. You start off with problem statement, customer says many profanities won't work. You then start asking queries of your data. Mm-hmm. At the same time, you probably got Jira open, or you've got a notepad open, or you got pen and paper, and you always forget to write down everything you did.
Yeah.
And then you kick yourself in the ass, and you have to figure it out later. Have you thought about the idea of having tools where, as you enter queries, you're enforcing a 5 whys methodology to help, 1, teach younger people how to troubleshoot, because they don't teach that in college, and 2, record what you're doing?
I don't know what that methodology is, but it's full. Have you seen our product?
Yeah.
Oh, okay. So that's a leading question. Excellent.
Yeah. Well, it's also, it's a leading question, but it's also how do we get that data into my notes without me having to do it because I'm lazy?
Totally. So the thing that he's referring to is, it is insane to me that we have all these tools that don't preserve our history. I learned Unix by reading other people's bash history files and just typing the commands to see what they did, right? Like human beings, we have this very social, we want to snoop, right? We want to look over the shoulder of the expert all the time and see what kind of queries they run because they probably know what they're doing, right? So we've baked that into Honeycomb. It's just the ability to, my history is there. So if I get paged about something and it's a Cassandra problem, I don't know fuck all about Cassandra, but I know that Ben and Christine do. And the last time we had a problem like this, I think Ben was on call. So I just want to go look at what Ben did when he was asking questions of the system and see maybe what he thought was important enough to post to Slack, maybe what he thought was important enough to put in a postmortem collection for that outage or something, because that's what I care about. These systems are so fragmented and large that even if I become an expert in this part of the system, that expertise lasts for about a month or 2, and then it starts to decay, right? I don't remember what I was doing when I was an expert in that system. I've got my notes, but I don't remember to write things down in my notebook either, right? So I want to just have access to what are the questions that I would ask when I was debugging a problem like this or someone on my team. We think about teams in much the same way we think about systems, and that single points of failure are not okay, right? And we can't all know everything about everything, but there's somebody around there, somebody around here probably does know that, and just having access to their brains is super important. So about how to like yank it back to your notes, we have talked a lot about Jupyter and shared notebooks, and we have a lot of stuff on the roadmap for Q2, I think, that is just like around the idea of a shared brain, right? The ability to ask questions of the data and to see what your team is doing. Hive mind. Oh, shit. Hive mind. Thank you. I owe you a beer.
Any other questions for Charity? Any other questions for any of our speakers tonight? All right, how about one last round of applause for all three speakers? Thank you all for coming out. The bar is still open for maybe another 20 minutes. Don't forget to collect some swag before you leave for the night, and have a safe trip back home. Thank you all for coming.